So now we get to talk about the relation of fractions in geometric series with the Barbell spiral. So what we're going to do is we're going to look at this fraction, the area of the spiral over the area of the original polygon, because our resource that we were required to look at has us look at that and look at these fractions, okay? Each piece of these fractions, this sum is going to add up to what the spiral itself, what the area of the spiral is in comparison to the area of the original polygon. So let's head back to the square. So to begin with, we have to figure out, well, how many times does this triangle fit in with this larger polygon itself? Okay, so this triangle, if we kind of look as 1, 2, 3, 4, and if we take a quick peek at this inscribed polygon, we can tell that there's 4 more in there. So together we have 8. So that's this 1/8 part. And then we move to look at this triangle and how many times it fits in there. But some people can say, oh, I looked, I could tell, but it's really hard to figure out sometimes. So one way you can do is you can look for the area. So here we found the area. Here we found the area of K, D, and E. So that's this area right here, KDE, so this triangle. Then we found the area of EFG, which is this area, and we can look at that, and EFG is exactly half of KDE. So we know that this triangle highlighted is half of this triangle that's now highlighted, okay? So that's how we can figure out the ratio for this, which is going to be 1/2, but it's much harder when we look at regular polygons like the hexagon. So the way we can look at the regular hexagon is the way we did it with the area up here, okay? Because it's much harder to take triangle FGE and try and figure out how many times it's going to fit in this large polygon. So the first thing we're going to do is we're going to find the area of the entire polygon. Okay, so now we have that area filled in. We're going to measure the area, and we get 132.59 centimeters, okay? And then we're going to say, okay, how many times can FGH? I mean, it's kind of hard to see, so we'll go ahead and we'll change the color of the larger one to blue. And then we'll grab this darker blue one, and we'll do the same thing. And I think I already found it. Yep, there it is. So it's 5.52 centimeters. So that's kind of hard. So in order to find the ratio and the relation between these two, we need to divide 132.59 by 5.52. If you take out a calculator, you're going to find that it's 24.0199 repeating. So if we round up, we round down really, but if we come to rounding, we find that it's about 24 times. So that means we have that triangle going in 24 times. So that's our first fraction. That's our original fraction, our first term. So that's it right there. That's where that's going to go. And we keep doing it. So next we'd move to finding IHJ, which I think we found, HIJ right there. And we do the same thing. We divide 132.59 by 4.14. And we get another one, which is actually, I'll write it again, 1 every 32nd, because we get the number 32.026, which we can round down and say it's just about 32. So you continue doing that, and then you need to find out what the relation is between 24 and 32, and the next one is actually 43, and then it goes 57, and then 76. So you have to find the relation. So you can divide 32 by 24 and find out that it's about 4/3, and that continues all the way through. So the ratio for the denominator of the fraction is going to be 4/3. So we're multiplying 24 by 4/3 to get 32. So that's going to be our ratio for this one. And using all these fractions and putting them all together helps us to create this geometric series that is eventually going to help us find out that this spiral, if we delete this lighter blue, because that's the entire area, this spiral, this red spiral right here, is about, just about, if we continued going, it would be 1/6 of the area of the regular size polygon. And we would know that because we would take each fraction that we came up with, how many times, like FGH and then GIJ and JXY continuing all fit into this polygon. We add them all together and we would get 1/6. And that would go for every spiral that we have. So if we continue doing this one, so on and so forth. So that's how we are going to talk about using fractions and geometric series when we're talking about the parallel spiral.